Looking at this view, you would never imagine how dangerous it once was and how dangerous it is.
The Mediterranean Sea has long been a crucial part of our planet's history, shaping civilizations and ecosystems for millennia. It has always been a symbol of connection and life, but once it faced a dramatic transformation that changed its course forever. In history, the Mediterranean experienced a catastrophic event known as the Messinian salinity crisis, when the sea nearly vanished. But recently, a giant underwater skeleton was discovered beneath the Mediterranean, offering new insights into this ancient event. So join us today as we explore the MSC and the fascinating giant skeleton that was uncovered beneath the waves. In 2011, paleontologists working on the Spanish island of Menorca made an unusual discovery.
You are having access to the mystic world of the seafloor, so you can see features that nobody else can see.
They unearthed the bones of a rabbit, but this wasn't like any rabbit you've seen before. For starters, this rabbit was a giant, weighing up to 6 times more than a typical cottontail. Its hind limbs were shorter than its forelimbs, and its feet ended in claws rather than the usual setup. And this rabbit almost certainly didn't hop. Its spine was stiff, and its toes were splayed, very different from the flexible spines and compact toes of modern rabbits. The researchers named this massive rabbit Neurologus rex, or the Rabbit King of Menorca, and determined that it lived on the island during the Pliocene epoch, around 5 to 3 million years ago. We've discussed insular gigantism before, where animals isolated on islands evolve into larger forms due to the lack of predators.
It's almost like a window back in time where you can see how it was when it was destroyed.
That seems to be the case with Neurologus rex as well, allowing it to grow so large. But how did the normal-sized ancestor of Neurologus end up on a Mediterranean island to begin with? It turns out the answer to this biological puzzle is tied to an even older geological mystery. Since the 1800s, scientists have recognized that the layers beneath the Mediterranean Sea's floor aren't just made of typical sediments like mud and sand. Instead, these layers are packed with salt crystals, huge amounts of salt, forming massive deposits known as the Mediterranean salt giant. Salt deposits like these are usually found in areas where bodies of water have dried up. This means that at some point in history, the Mediterranean Sea must have evaporated. But how could a sea as vast as the Mediterranean just vanish? It would take decades and over 1,000 research studies to begin uncovering the reasons behind one of the most significant disappearances in Earth's history.
Scale of the site. Much of the focus has been on the resort area of Baiae itself, but on the margins of the site, there are constantly new areas coming up.
That's it, slow it down. There's a lot down there.
Today, ocean water flows into the Mediterranean from the Atlantic through a narrow channel between Europe and Africa called the Strait of Gibraltar. This is the sea's main water source. Some fresh water from rainfall and rivers also flows into it, but without the Atlantic water, it wouldn't be enough to keep the sea full, as the Mediterranean has very high evaporation rates. To geologists investigating the salt giant, it seemed as though the Mediterranean's main water supply had been cut off, like shutting off a faucet to a bathtub. This event was named the Messinian salinity crisis, or MSC. However, figuring out how this water source was blocked wasn't straightforward. Since the 1970s, researchers have debated the details. How did it happen? How long did it take? Eventually, they proposed 3 main hypotheses to explain how the salt giant formed. At first, some scientists believed there was a global cooling event at the start of the crisis during the late Miocene epoch, around 6 million years ago. If the entire planet had cooled into an ice age, a large amount of ocean water would have frozen into glaciers. This would have lowered sea levels and reduced the flow of water into the Mediterranean from both the Atlantic and surrounding rivers. An event like this would have needed to be global rather than local. However, this idea was disproven fairly quickly. Shortly after the salt giant was discovered, researchers began analyzing oxygen isotopes and other geochemical data from sediment and ice cores from around the world. Their findings showed that the rest of the planet wasn't unusually hot, cold, or dry during the crisis. Additionally, they discovered that some of the salt deposits were formed before any significant changes in sea level occurred. This meant there wasn't a cooling event large enough to cut off the flow of water, ruling out the first hypothesis. The second idea suggested that tectonic activity had blocked the Mediterranean from the Atlantic, cutting off its water supply. Some scientists propose that movements in the ocean crust slowly closed the waterway between the two bodies of water. As the remaining water in the deep basin evaporated, it became increasingly salty, leaving behind layers of salt as it dried up. And this explanation was almost correct. Some scientists propose that the Mediterranean dried up due to a combination of shifting crusts and climate change. This was the third theory. In this model, the crust beneath the Strait of Gibraltar gradually rose, reducing the flow of water from the Atlantic Ocean. At the same time, regional climate changes, like periods of lower rainfall and higher temperatures, affected the amount of fresh water entering the Mediterranean. According to this idea, the MSC didn't occur all at once. Instead, the water levels began to drop after the strait closed and continued to fluctuate with changes in the climate. And this theory turned out to be pretty accurate, or at least close to the truth. As geologists collected evidence to test these ideas, they discovered that the MSC was indeed driven by shifts in Earth's crust, but these shifts happened repeatedly rather than all at once. For instance, in sediments near the Nile, geologists found signs of repeated erosion events, rather than evidence of a single massive event. This indicated that the water level dropped, stabilized to create a new shoreline, and then dropped again several more times. Some researchers estimate that there were about 16 climate cycles during the early stages of the MSC. These changes also aligned closely with what is known about climate cycles. When sea levels dropped, the Earth's position and angle relative to the Sun shifted, leading to periods of lower solar energy and others with higher solar energy, which increased evaporation rates in the Mediterranean. Meanwhile, an actively folding and rising tectonic belt further reduced water inflow into the region. Scientists used chemical and magnetic signatures in the sediments from this period to estimate how long the MSC lasted. The data indicates that it persisted for over 600,000 years, with the driest period occurring around 5.6 million years ago. During the peak of the MSC, external water sources were completely cut off and much of the water remaining in the Mediterranean basin was evaporating. Experts believe that the water level dropped by several hundred meters, comparable to the length of multiple American football fields. The remaining water became supersaturated, leading to salt continuously precipitating out onto the seafloor. The longer the salty water remained, the more salt was deposited, resulting in layers that may be up to 3 kilometers thick. This shows that the sea remained extremely salty for hundreds of thousands of years during the MSC. This dramatic change had significant effects on the organisms in and around the Mediterranean. Life in the sea back then was profoundly different. Today, the Mediterranean Sea is home to thousands of marine species and is well known for its crystal-clear blue water. However, there was a time when the sea nearly dried up completely, making it uninhabitable. Hardly anything could survive in such conditions. Most of the animals and plants that once thrived in the Mediterranean either migrated elsewhere or died off because the water became too salty and too shallow. Some marine paleontologists believe that no true marine organisms were able to survive, and there's solid evidence to support this idea. For instance, the sediments deposited during this time show no signs of disturbance, indicating the absence of burrowing creatures. Even today, there are very few deep-sea species unique to the Mediterranean, as most were wiped out during the MSC. Some shelled creatures, like gastropods, may have survived, but their existence was far from easy. Sediment cores reveal that small populations might have managed to survive in isolated pockets. But the sea's disappearance wasn't entirely bad for all living things. The lower water levels created opportunities for some species to thrive. Fossil distributions of now extinct megafauna suggest there was once a land bridge connecting the mainland to several Mediterranean islands, like Sardinia and Corsica, which no longer exists today. This allowed hippos, elephants, and other large animals from Africa to cross and swim through the Mediterranean. And it's clear that it wasn't only the megafauna that took advantage of this crisis to move around. This appears to be when the ancestors of Neuralagus, our giant rabbit friend, made their way from the European mainland to Minorca. Paleontologists have also discovered other giant species, like dormice and hamsters, on islands that have been separated since the MSC, such as Malta and Sicily. This wasn't the first instance of animals traveling long distances to reach new lands around the Mediterranean. It was just one of several migration events during the late Miocene. The evidence of these migrations is found in the fossilized remains of the hippos and elephants that once roamed there. However, when the water levels rose again at the end of the MSC and the land bridges disappeared, these populations became isolated from one another and from northern Africa. This isolation resulted in smaller versions of large animals, known as insular dwarfism, and larger versions of small animals, or insular gigantism, on islands around the Mediterranean. This helps explain how Neuralagus made it to Minorca and why it grew to such a large size. Of course, the Mediterranean Sea reformed over time, meaning the water eventually returned. Models of the ocean crust indicate that the Strait of Gibraltar opened as the tectonic plates shifted, and as sediments eroded, the barrier between the Atlantic and the Mediterranean was lowered. This allowed water to flow through the strait and into the basin. However, just like with the theories on how the MSC began, there was considerable debate over how it ended as well. Initially, some scientists proposed that a massive waterfall poured into the Mediterranean, filling the basin so quickly that it took only a few months for the sea to replenish. Sediment deposits were even found that hinted at a rapid flooding event. But while that theory was intriguing, it seems unlikely, at least not the part about a waterfall. More recently, geologists using seismic data found that the slope between the Atlantic and the Mediterranean wasn't steep enough to support such a waterfall. Instead, it's now believed that the sea was likely refilled by a river-like flow. The basin did fill up quickly, though. Recent estimates suggest it took around 2 years to end the MSC, during an event now known as the Zanclean Flood. But that doesn't mean the story is over. The Earth's plates are always in motion, and if the right combination of plate movement and climate change were to occur again, a similar event could, in theory, happen once more. Scientists continue to uncover more evidence of the MSC, from fossilized mini-elephants and Neuralagus to salt crystals discovered both on land and beneath the Mediterranean Sea. While some events leave clear marks on the planet's surface, such as mountains and craters, others are harder to spot and require a closer look. Although the MSC shaped life around the Mediterranean for hundreds of thousands of years, its impact is largely hidden, buried beneath the waves. However, the fossils of dwarf elephants and giant rabbits give us a glimpse of its effects and serve as a reminder of that moment in geological history when the Mediterranean Sea vanished. The disappearance and reappearance of the Mediterranean Sea is not only an extraordinary event in Earth's history, but also a reminder of the planet's dynamic nature. The story doesn't end with the Zanclean flood or the refilling of the Mediterranean basin. Instead, it opens up an array of questions about how such a massive geological transformation influenced evolution, climate, and ecosystems worldwide. One of the lingering questions relates to the long-term effects on global climate patterns. A sea that essentially vanished for hundreds of thousands of years and then returned surely had ripple effects far beyond its immediate geography. The evaporation of such a large body of water during the MSC would have released immense amounts of salt into the atmosphere, potentially altering atmospheric circulation and impacting regions as far away as Asia or the Americas. Researchers have hypothesized that this could explain some of the significant climatic shifts during the Miocene and Pliocene epochs. However, the exact extent of these changes remains an area of active investigation. Another fascinating avenue of exploration lies in the genetic history of the organisms that survived this cataclysm. While most marine life perished during the MSC, some species managed to endure in isolated pockets, evolving into forms better suited to extreme conditions. These survivors left genetic clues that scientists today can use to study how life adapts to extreme environments. Modern-day extremophiles, organisms that thrive in harsh conditions, may provide insights into how ancient species survived during the MSC. These insights could also have implications for astrobiology, as scientists search for life in extreme environments on other planets. Equally intriguing is the impact on human evolution. Although the MSC predates the appearance of modern humans by millions of years, it may have indirectly shaped the environments that early hominins encountered. The land bridges that formed during the MSC facilitated migrations of animals, which could have influenced the distribution of prey species that early human ancestors relied upon. Moreover, the dramatic geological changes in the Mediterranean region might have contributed to the diverse ecosystems that later became home to early human civilizations. The Zanclean flood, which marked the end of the MSC, also left geological signatures that scientists are still studying today. These signatures help refine our understanding of how rapidly Earth's crust can shift and how resilient ecosystems are in the face of such shifts. The reflooding of the Mediterranean may have been one of the fastest large-scale geological events in Earth's history, a stark contrast to the millions of years it took for the MSC to unfold. This rapid refilling likely caused dramatic changes in the surrounding landscapes, wiping out some habitats while creating new ones. Rivers and deltas that had formed during the dry phase were submerged, reshaping the region's geography. In the present day, the Mediterranean Sea continues to be a region of geological and ecological interest. The tectonic activity that caused the MSC is far from over. The Mediterranean is still a hotspot for earthquakes and volcanic eruptions. The slow but relentless collision of the African and Eurasian tectonic plates will eventually close the Mediterranean entirely, though this process will take millions of years. In the meantime, scientists are using the Mediterranean as a natural laboratory to study how tectonic forces shape the Earth's surface. One of the most exciting developments in recent years has been the discovery of ancient microbial life trapped in salt crystals from the MSC. These microbes, which may have been preserved for millions of years, provide a direct window into the past. By studying them, researchers hope to learn more about the conditions during the MSC and how life persisted through such a harsh period. These findings could also inform our understanding of how life might exist on other planets with extreme environments, such as Mars or the icy moons of Jupiter and Saturn. The MSC has also inspired a renewed interest in the study of deep time, the vast expanse of geological history that predates human civilization. Events like the MSC remind us that the Earth is constantly changing on scales that are almost impossible to comprehend. They challenge us to think beyond the human timescale and consider the long-term consequences of natural and human-induced changes to the planet. After the Messinian salinity crisis, MSC, a bizarre discovery was made deep beneath the Mediterranean Sea, the skeletal remains of a giant creature unlike anything ever documented. The skeleton, discovered by a team of marine archaeologists exploring the ancient seabed, seemed to belong to a creature that was both human and something else entirely, an ancient colossal being that had somehow survived the cataclysmic events of the MSC. The skeleton, which was estimated to be over 15 feet tall, had features that appeared almost humanoid, but with strikingly different proportions. Longer limbs, an elongated skull, and a body structure that suggested it had adapted to the unique conditions of the pre-MSC Mediterranean landscape. Some theorists believe this could be evidence of a forgotten species that lived during the time before the Mediterranean Sea vanished. The discovery sent shockwaves through the scientific community, raising more questions than answers. Was this an ancient human ancestor, or was it an entirely different species? How did it survive the extreme changes of the MSC? As researchers continue to study the remains, the mystery deepens, and the Mediterranean's history becomes even more enigmatic. Some speculate that this find could rewrite our understanding of life in the ancient world, leaving us to wonder what else still lies hidden beneath the waves. Thanks for watching. Don't forget to like, subscribe, and share your thoughts in the comments below. I'd love to hear what you think.